Right? Hold on. It's too loud. 3, 2.
The City of Dimsdale understands that you plan to construct a rectangular pin so that the length of the pin abuts the highway. We understand the need to divide the pin into 2 smaller pins with fencing parallel to the width, as well as the need for the pin to have an area of 18,000 feet squared. Because the fencing next to the highway needs to be constructed with higher gauge chain link fence, the cost for that length of fencing will be $18 per foot, while all other fencing costs $10 per foot. You need to present to the City Council a function to model the cost of the entire pin in terms of the width of the pin, X, the minimum cost your company will incur to build a pin meeting the requirements, and what widths would satisfy the zoning restriction of only spending $10,000 on a project directly next to the highway. Thanks, Doug Dimmadome, owner of the Dimsdale Dimmadome.
So first, I have to draw a picture to represent the pen. Next, I need to label my sides. The shorter side I will label X, and the longer sides I will label Y. After that, I need to write the cost per foot of the fence on the picture. All of the sides except for the one against the road will be $10 a foot, and the one next to the road will be $18 a foot. What I need to find now is the independent and dependent variables. I need to write my formulas. I know that the area equals X times Y, and that the area is 18,000 feet. Therefore, X times Y equals 18,000. Perimeter is equal to all the side lengths added together. There are 3 side lengths, where there are 3 sides with length X and 2 sides with length Y, so the perimeter equals 3X plus 2Y. I need a formula to find the cost of all of the side lengths. So we insert the cost per foot as a coefficient of each side, variables, in the perimeter formula, as that is the formula that details the amounts of sides and side lengths. However, the 2 Y side lengths have different cost values, so you split them up, making the formula cost equals 18Y plus 10Y plus 3 times 10X. The 3 coefficient is there because there are 3 sides with that length. For the equation though, I need to find the entire formula in terms of one variable, X. So we need to find Y in terms of X and replace the Y variable in the equation with that phrase. To do this, I can use the equation X times Y equals 18,000, as it is the simplest formula with both variables. So to get Y by itself and get it in terms of X, I will divide by X on both sides, and I end up with Y equals 18,000 divided by X. I then use substitution to change all the Y variables to that phrase. Once that is completed, the final formula should be 18 times 18,000 over X plus 10 times 18,000 over X plus 3 times 10X. To find the minimum cost to meet the requirements of the pen, I must first go onto Y equals on your calculator. I plugged in the cost equation, then pressed the window button. I changed the X max to 1,000 and the Y max to 25,000 to fit the graph. Press on the trace button. To find the minimum cost, I pressed second calc, then went to the minimum. Once I pressed the minimum, I moved the dot on the left bound part of the function and pressed enter. Next, I went to the right bound side and pressed enter. Pressed enter again, and the Y value is the minimum, or $7,776.89. To find the widths of the pen that satisfy a cost of $10,000, I need to plug in another function. C of x equals 10,000. Then I go back to the graph, press second calc, then go to intersect. I need to enter the first curve on the left of the one function, then go to the second function and enter the curve on the left as the second curve, giving me one width. I need to repeat this with the right side of the functions, and this gives me the second width. The two widths that satisfy the $10,000 cost requirement are 61.89 feet and 271.44 feet. The side length is either 61.89 feet or 271.44 feet. To the City Council of Dimsdale, I will present to you the proofs of the zoning requirements. C of x equals 28 times 18,000 divided by x plus 30x. B. $7,776.89. C. 61.89 feet and 271.44 feet. Thank you. Samuel L. Jackson.